Good morning, everyone. Now we will see the AC voltage controllers for single phase and three phase induction motors. So already we have seen few configurations in the previous class, namely A, B, C, D for three phase induction motor, because for three phase induction motor you will have two different type of winding connections, namely star connection as well as the delta connection. So based on the winding connections as well as the based on AC voltage controller connections, will have different combinations. So all these different combinations have been shown here. Um, A, B, C, and D. And coming to this figure, the last one, which is a single phase connection. So here the input is a single phase AC supply, and the load is a single phase motor, which means the stator winding contains a single winding because it is a single phase. So single winding, and this is a normal AC voltage controller, generally shown with the triac switch. This is a triac switch, or you can use two thyristors also. You can use two thyristors also in the place of this triac controller. Okay. In domestic fan motors, which are always single phase, in our domestic homes, we have seen a single phase fan motors which are single phase, controlled by single phase triac voltage controllers. Means like this. This is a simple circuit diagram of a triac controller for a single phase induction motor. So speed control is obtained by varying the firing angle that is given to this triac. If you use thyristors also, we have seen the same operation in AC voltage controller concept in the power electronics subject, as well as we have done the experimentation in the power electronics lab also. So by controlling the firing angle, we can control this AC voltage controller. Means a thyristors or a triac, anything, any switch. These controllers are commonly known as solid state fan regulators, and these are preferred nowadays over the conventional controllers, because the conventional controllers, what we have seen in the earlier days, are variable resistance type regulators. But those variable resistance type regulators are not efficient or inefficient. Those conventional controllers are replaced with the AC voltage controller, like a triac, using thyristor switches or any other. So using AC voltage controller, the efficiency of the entire system will be increased. That is the advantage of power electronic converter or power electronic circuit. This power electronic circuit improves the efficiency of the entire system, which cannot be achieved with the conventional controllers. Okay. And similarly, we have seen different figures here for the three phase also. So the circuits shown in these figures are the three phase balanced circuits with six thyristors. You can see here you will find six thyristors. Here you will find six thyristors. I'm sorry. Here you will find six thyristors. Here you will find six thyristors. Okay, all these are uh, AC voltage controllers with the six switches, and the performance of these circuits, circuit number A, circuit number B, and circuit number D, are very good. Except C, remaining three circuits A, B, and D are good because they are very much balanced. They are very much balanced, and the percentage of increase in input current that is taken from the input supply. Input current is at 2/3 of the synchronous speed, which is about 10 to 15% only when compared with the sinusoidal voltage control. So when compared with the normal sinusoidal voltage control, the input percentage of the current that is taken from the input terminal for a 2/3 synchronous speed, 2/3 of the synchronous speed. So synchronous speed into 2 by 3 times is about 10 to 15%. And the stator connected winding gives a better performance with the delta connected one, because the delta connected converters having an advantage of eliminating third order harmonic, because the delta connected connection will always eliminate third order harmonic because of its connection. If you write the mathematical expression, then all the third order harmonic terms will be eliminated for the delta connected connections. So that means delta connected connection is very much effective because it eliminates the third order voltage produced or generated in the back EMF of the motor. And because of this third order harmonic, generally this harmonic increases the losses and thermal effect or thermal loading in the motor. The losses are increasing means losses will obviously produces the heat in the motor, right? So that means the heat of the motor increases, which increases the thermal loading. Simply we can say in technicality, thermal loading of the motor is increased due to the losses. So third order harmonic is very much effective in the reduction of efficiency. But this delta, if we use a delta connection, then simply we can eliminate the third order harmonic, so the losses can be minimized, the problem can be solved that is happened due to the third order harmonic. And the speed control of this induction motor can be obtained with the help of, you can see here, thyristors, right? These thyristors, we will give the triggering pulse. That triggering pulse can be controlled by the firing angle. So if we control the firing angle, which means in the AC voltage controller we can regulate the firing angle alpha from 0 to 180 degrees, so that for a different firing angle the output voltage of that particular instant will be modified accordingly. So like that we can control the speed of the induction motor, that we have seen for single phase in the power electronic subject. For the three phase also it is pretty much same. And each thyristors means which are connected in anti-parallel, you can see here the anti-parallel connection of thyristors. If we want to use a triac, simply this anti-parallel connection of thyristors can be simply replaced by a triac switch like this. You can simply replace this anti-parallel thyristors by a triac switch, because triac switch represents anti-parallel connection of two thyristors. It will triac will operate for both the current directions. So simply if we want to reduce the number of thyristor switches, then we can simply use triac. Then these two, in the place of two thyristors, one triac is enough to perform the same operation. Okay. Since the voltage controllers, AC voltage controllers, are of both single phase and three phase, allows stepless control of voltage from its zero value. So that means they are also used for soft start of motors. So in order to run the motor, in order to start the induction motor for the soft start, then these controllers are very much helpful. With increase in firing angle, both distortion factor and displacement factor reduces, which reduces the power factor. Means, see, every power electronic converter generally suffers with power factor issue at the input terminals. You know what is power factor. So always the input terminals must maintain unity power factor. But with the use of power electronic converters, which are non-linear converters, so due to these non-linear converters, definitely the input power factor will always affect. So if the power factor is affected at the input terminal, then we need to correct or we need to improve the power factor at the input terminal. For that, we need an extra circuitry or extra control mechanism in order to improve the power factor at the input terminal. That is very much essential for the power electronic converter circuit, which is a major disadvantage. Because all the power electronic converters are non-linear circuits, definitely every non-linear circuit will produce power factor issue at the AC input terminals. This is very much important point. You remember this one. Okay, for any of the circuit, either it may be three phase or single phase or anything, if we are using a power electronic circuit, then it will create power factor issue because the distortion factor is very high along with the displacement factor. So those causes the poor power factor at the input terminals. Okay, and the operation of this single phase AC voltage controller and the operating waveforms, you are very much know. You have seen already this in the power electronics. You once check the power electronics textbook for the detailed operation. And coming to its advantage and disadvantage, advantage first we will discuss with discuss the advantage of stator voltage control, and later we will see the disadvantage. Now coming to the advantages, see the control circuit required is very simple because only we need to get the firing pulses because all are thyristors, so only firing pulses are enough to control the thyristor switches or the triac switches. So the control circuitry to produce that firing pulses are very much simple. So that means the control circuit that is used for this connection is very simple. So the control circuit is simple. That means the compact, the total system size will be compact and weight also less. That is also an advantage, added advantage. And quick response is possible, which means the system, the machine will respond very quickly. That is also one of the advantage. And it is very economical, so that we can save the energy. So all these are the advantages of a stator voltage control. But we have several disadvantages also. As discussed, the power factor, input power factor is poor because of non-linear circuitry, because of power electronic circuit. The distortion factor and displacement factors are high, which means because of the power electronic switches, the harmonics will be produced. Because of the harmonics, the power factor will get uh, decrease or will be poor. So the poor power factor is the major disadvantage, one of the major disadvantages. So in order to get rid of this disadvantage, we need an extra circuitry in order to improve the power factor or extra control mechanism, so that we can improve the power factor at the input terminals. Every power electronic converter must need this to improve the input power factor. And performance is poor under low speed running conditions, because under low speed running conditions, slip will be very high. We know slip is omega s minus omega m by omega s, where omega s means synchronous speed, omega m is actual speed. If the actual speed is very low compared with the synchronous speed, then slip will also very high. And slip and efficiency relation, we have seen that efficiency is 1 minus slip. If slip is high, then the efficiency is also poor. If slip is high, then efficiency is poor. So that is the major disadvantage. So very low speed conditions, it is not suitable. because for very low speed conditions the slip is very high. And at the same condition, the ohmic losses are also high. Operating efficiency is low as ohmic losses are high. See, just now we have seen the efficiency is low because of the low speed. So if efficiency is low means the losses are high, and the slip is the reason, and this slip is directly proportional to the rotor resistance, which is RR dash. The rotor resistance, the slip is directly proportional to the rotor resistance, which means if the slip is high, then the losses on the rotor resistance is also high. In the previous class, we have discussed this one also. This overheats the rotor part of the induction motor, so which is also one of the major disadvantage. Ohmic losses are high. Ohmic losses means the resistance losses, which creates heat or overheats which overheats the rotor part of the induction because of more losses. That is also one of the major disadvantage. And as the stator voltage decreases, the torque is also decreases. This we have observed in the torque speed characteristics with voltage different voltage. We have drawn the torque speed characteristics like this. We have drawn these curves like this. So this is the maximum torque for this particular voltage. Suppose this voltage is V4 and this voltage is V1. Now you can see the maximum torque of V1 is very much high compared with the maximum torque of V4, because V4 is very much less than V1. So this is also one of the major disadvantages. The maximum torque capability of the induction motor will also get reduced because of the voltage, stator voltage. If we decrease the stator voltage, then the maximum capability of the torque production of that particular induction motor is going to reduce. So all these are the different disadvantages with the stator voltage control. Okay, thank you.